Hey guys, so in the previous tutorial we worked on how to start to generate some of this strip geometry, which we're going to come back to at another time, but today we're going to focus on generating what we're going to refer to as the carcass geometry, which is all the geometry that all the strips sit on. So what it's essentially going to be is based off these ISO curves, and then we're going to sort of offset them and do a bit more, and then eventually turn them into 3D geometry that we can start to cut up in further videos for fabrication. So the first thing that we're going to do is, I'm just going to pull this off and drag it down here. So these are the carcass curves, and we're going to offset them in. Except we're going to use offset curve loose. And the main reason is, if I pull both of them up, one takes ages to load because it wants to offset them perfectly. Let's just go 54 and chuck that in there. See how it takes a good couple seconds to load. Oh. Maybe a couple more. Oh, there we go, 7 seconds. And don't worry about what direction it offset it in, but either way, it takes a while. Versus offset loose, which is a lot quicker. It's because it wants to preserve like a lot of the information about the previous curves, and tries to offset it like perfectly. Whereas we want to offset these negatively just to make a bit of a internal, give it some thickness, right? We don't really care about the shape of this curve. We care about that outside curve, but not the inside one, which is why offset loose is perfect. Now, what I also want to do is when we, we're going to be cutting these shapes up for CNC fabrication, and all this curvature inside, it's not needed. So I'm going to use convert to poly. So I'm going to convert, where is it? Convert to polyline. Awesome. So there we go. So I want to convert all these curves into closed polylines, because having like straight edges versus curves when it comes to CNC fabrication is good, because it allows you to nest things a lot tighter, and we'll come to learn that through our OpenNest plugin, it likes polylines over curves a lot of the time. So let's just chuck that in. These initial settings are okay. I'm just going to put in a tolerance angle, and it wants radians, so we'll put that in, and we'll make it around 90, I think. So I think that converts to like, what is it? Is that half radian? Yeah, there you go. Cool. So we'll do 90, and we'll do a like a minimum. Put a minimum edge in there of maybe about 200. See what that looks like. And just sort of keep our old curves open. See if we make that, we start to bring it down a bit. There we go. We want to still have a polyline that looks like our original curves, but is still a polyline. Awesome. So now what we want to do is turn these into some surfaces. So we'll merge this polyline with our first curve. Have a look at the data structures. Why don't we just simplify that down to make things easier? It looks like it wants to, be alright. And then I should be able to turn that into some boundary surfaces pretty easily. And we have. Awesome. Now let's go through and generate some 3D geometry from that. Now, in terms of like fabrication, I want to cut these out of maybe like 18mm plywood, hence the 18. And then I'm going to have to evaluate surface, because I want to extrude these out, and evaluating the surface gives me the normal vector of each surface. And I'll just reprioritize that. Cool. So now we've got our normal vector, like our vector that's pointing that way. So let's start to build this up on the amplitude vector, and then what I want to do is I want to extrude both sides out. So what I'm going to do is divide that by 2. First, I'm going to move this surface back a little bit. So let's have a look. You can see how that's moved back. Yep. And then I'm going to extrude it. I'm going to extrude that. New vector along 18. Out that way. Cool. So you can see I should have... Oh, I think I have to do that negative just for now. Cool. There you go. So then you can see that that extrusion has happened, and it's still maintained that center line, which it's always good to maintain center line geometry in case you need to come back to it and alter it in some way or do something to it. It's like having a center as a datum. And yeah, so I think we'll leave it there for now. A nice little short one. So as you can see, we're starting to generate something that you can actually make from this. And we'll have to there's a lot more steps left to go. But in the next video, we'll work on generating what do we call it? We'll call it some rail geometry. The rails that'll connect all these carcass sections together. Awesome. Well, I'll see you in the next video.